How do we find out important words in a natural language processing application? So if I have an example such as we have two sentences, number one is a boy is playing football and the other sentence is a boy is smiling. So if I say that first sentence, if I take it as document 1 and I present it as by D1, and the second sentence which is a boy smiling as document 2 which is D2, and we want to apply some class or label to these two sentences, and I say that we have two classes only, one class is sports and the other one is close up. So if I want to apply these two classes on our two sentences, so what we can say that a boy is playing football, it should be a sports class, and then a boy is smiling, it should be a close up class. So how do we achieve these things, and what are different parameters or options available in natural language processing domain for this automatic classification? So for automatic classification, again I am repeating that it is just putting some label, some tag or some class to our provided text. Example of this thing can be if we have some paragraph and if we want to apply a heading to that paragraph, that heading would be a class and that paragraph would be our document. So in this analogy I am saying that two sentences which are written here, these are our document 1 and document 2. So number one basic feature in any text can be, we can say that if any word has most occurrences in a text, we say that this text belongs to that word. For example, if we have a text and what we say that in text how many words are occurring and what is the frequency of those words. Suppose in a specific document most occurring word or the most frequent word is hockey, then we will say that it is a sports scene. And if the most occurring word is smile or happy, we will say that it is a close-up word. So based on this definition, we say that number one feature can be occurrences of words, and then these occurrences should be modeled with the help of other content words, which we already said that the most important words are nouns, verbs, adjectives and so on. Based on these definition, we come to the first statistical testing or feature extraction mechanism, which is basically term frequency. So here I have given term frequency information with another measure, which is term frequency inverse document frequency, which is shown by this equation. So this equation is basically combination of two terms. First one, this one is term frequency and this one is inverse document frequency. What is explanation? Term frequency, this term basically, it is combination of, or it tries to find out frequencies or number of occurrences of this term inside this document. So in one document, a specific term, how many times it has occurred, it is given by term frequency. The next thing, this one, inverse document frequency. So whenever there are terms which are occurring in most of the documents, then they lose their information. As in our previous example, which we are working on this slide, a boy is playing football, a boy is smiling. So boy, by definition, when we said that noun is the most important word, if I take boy, so boy is present in both the documents. So what will happen? It is not good candidate for classification of these documents. So we want to remedy this information which is boy. So for remedying this information, we have to take the inverse of those documents in which boy has occurred. So moving on, we have for term frequency information, we have taken this equation, which basically presents two things. Number one, NTD. NTD is basically number of occurrences of a term in a document D. Such as, suppose we say that boy has occurred 15 times in our document, so NTD will present 15 value. On the other hand, this downside, this denominator basically, it presents number of occurrences of all the words in a document. So 15 divided by, suppose there are 100 words in the document, so 15 by 100, what it will be do? It is a basically normalization factor, so it will convert probability of things, basically it will convert number of occurrences in a probability value. Probability value is between 0 and 1, and it will keep our calculations simple. Similarly, inverse document frequency, which is shown by log d by wt. Wt is the number of documents containing the term t. And finally, I have listed this information which is shown in the form of a matrix. So what this matrix is presenting, at every cell we are taking combination of term frequency with inverse document frequency. So because this is a matrix and at every cell we have combination of two things, number one TF and then IDF. So term frequency combination with inverse document frequency, we make a matrix which is TF-IDF matrix, and it is used for further processing. So what was missing in term frequency or term information, term frequency, inverse document frequency? At the start of this module, I said there are three things. Number one, documents, which were shown by D1, D2. Then we have our terms, which were boy walking, boy playing soccer, etc. And the final thing was classes. In TF-IDF and in TF, class information was missing. So now we want to put that class information in our framework. For that purpose, we use other feature extraction methods such as chi-square, and the other method is map estimates, which will be shown later on. So another thing which is added in chi-square is that is basically it will evaluate independence between events also. So between events means in our case independence between our terms. So boy and playing and soccer, how independent they are. So for this purpose we have to take, or we have to see the definition of chi-square, which is shown in this slide. Basically what we have four different parameters which are F11. So F11 stands for all the number of documents which are belonging to class C and which contain term T. So for example, if we have a word play, so it corresponds to class sports and it contains term T also. So these are all the documents which are having this information. Then F10. So F10 are the documents which are not in class C but contain T. Then F01 and F00. So combining all these four information in this formula, what we get chi-square values for each individual term in relation to some specific class for a specific document. Now we come to the final feature extraction measure which is presented in this module, which is map estimates. Map stands for maximum a posterior probability. So what is idea behind this thing is that it will try to find out most importance of terms against a class C. So what is basically focus? This thing. So what it is presenting, NTC, which stands for numbers of term T in class C. And then this NT, basically this one, number of terms in the entire corpus. And NC is basically our number of distinct classes. So basically it is combination of these three things, NTC, NT and NC. NT given C, basically number of terms in the class C, and so on. And what is PMAP C? So basically it is the maximum probability of a class C which has ND by C. ND by C is the number of documents in the class C, and ND is the entire number of documents which are present in our corpus. And then we have two parameters, alpha 1 and alpha 2, which should be determined empirically. Empirically means by experiments, and to keep the values in some specific range, which is basically most of the time between 0 and 1.